Hello everyone. This presentation will cover the topic of corrosion in electrical transmission towers, and the focus will be placed on common types of corrosion, evaluation methods, and mitigation techniques commonly used in industry. First, some background information on electrical transmission towers. The type of electrical tower focused on this presentation was a metal structure used to support overhead AC or DC lines to provide electricity to society. AC voltages can reach up to 380 kilovolts, while DC voltages are typically found in the 10 to 30 kilovolts range. It is not uncommon for a maintained electrical tower to last 20 to 35 years without any major failures or corrosion problems. However, if corrosion in these towers is not addressed, complete tower failure can occur in less than 10 years due to the exponential nature of corrosion rates. Electrical transmission towers are made of 4 common materials: galvanized steel, weathering steel, wood, and concrete. Often aluminum wire is used for the transmission lines due to its high electrical conductivity and low cost. Transmission towers are generally susceptible to 3 major forms of corrosion. Uniform corrosion occurs because the towers are exposed to a very wide array of environmental elements, including UV light from the sun, moisture from the air and rain, and wind. In addition, the geographical location of the towers plays a significant role in the presence of uniform corrosion. Coastal towers are exposed to sea salts in the air. Towers in hot, humid regions are exposed to high moisture content, which can accelerate corrosion rates due to high oxygen content in the air. Dry and dusty environments can cause accelerated wear on the galvanized protective zinc coating on the steel. In addition, the environmental effects, the ultra-high currents and voltages in the wires create induced electric fields away from the actual wire. This can set up electrical currents in the steel members, thereby accelerating the corrosion rates. Crevice corrosion is another form of corrosion whereby a small region adjacent to the nuts or bolts become depleted of oxygen, causing a reaction between the iron in the steel and the hydrogen ions from the moisture of water. This creates a drastic drop in pH level, which causes an acidic region and accelerated corrosion rates locally. This emphasizes the importance of eliminating crevices and humidity on the structure. Stress corrosion cracking is another form of corrosion in which a threefold combination of material, environment, and mechanical stresses create a situation where the material corrodes under stress. This often results in failure well below the yield strength of the material. Failure can occur suddenly and unexpectedly. Failure to identify corrosion problems in these transmission towers can result in catastrophic failures. However, there are non-destructive methods for identifying the types and severity of corrosion, so that preventative maintenance or repairs can be made. Visual observation is the most common method for identifying corrosion in electrical towers. Often, companies divide the condition of corrosion into different phases, as shown in this table. More significant repair methods are required as the phase of corrosion increases. It is not only safer to identify corrosion in its early stages for ease of repair, it is also significantly cheaper to do minor repairs such as reapplying a protective coating as opposed to replacing the entire structural members. There are several non-destructive tests that are used for corrosion identification. Many of them rely on the same principle. Waves are transmitted through the material, and the received signals are recorded to identify irregularities in the material. Magnetic flux testing is used to identify magnetic leaks in the material, which are cited where the metal has corroded. In addition, ultrasonic testing and guided wave testing are both used to detect material flaws. Guided wave testing uses a transducer to send long-distance signals through the metal, whereas ultrasonic tests are used to identify surface flaws in a more localized area. Preventing corrosion cannot be accomplished without regular maintenance schedules. During a maintenance or repair schedule of the tower, a cleaning of the structural member using hand tools such as grinders and polishers is often performed prior to the reapplication of a protective coating. Protective coating are the primary method for preventing corrosion of the steel. In addition, sacrificial anodes are used at the base of the towers to prevent the corrosion of steel. These anodes also require monitoring, as they must be replaced regularly in order to continue protecting the steel. There is also a grounding path on all electrical towers to direct lightning strikes to the ground and prevent high electrical surges in the structure of the tower. This is an example of the effort that goes into some of the maintenance of transmission towers. While this is not an electrical transmission tower, it does not illustrate the importance of preventing corrosion in these towers. A great deal of effort is spent just getting access to some of these areas, and if it is very difficult to replace parts such as elevations. Thus, the prevention of corrosion is important part longevity and for minimizing the numbers of inspections of this magnitude that are needed for each tower. So we can put Alright, thank you very much.